Hello everyone, welcome to another video from Advanced Math Tutors. Today in our series on Calculus 2, I wanted to bring you a video explaining partial fraction decomposition. Now, partial fraction decomposition actually has nothing to do with calculus, it's a purely algebraic technique. But if we apply it to certain calculus problems, it'll make our lives a lot easier, make the problem simpler. And now what partial fractions decomposition says, let's say I have a function that looks like this, where I can factorize the denominator, just like this, into some factors. Here I just chose x minus 2 and x plus 3. What partial fractions decomposition says is that I can decompose this one polynomial into the addition of two polynomials like this, where I have one constant over one of the factors plus another constant over the other factor. And you may look at this and say, wait a minute, you can't do that. And in general, you can't, but it turns out if you have the right A and the right B, you can do that. And so if you go to an institution where they teach this, no one's going to give you the proof of why you can do this. They're just going to tell you to accept it without proof. And that's what we all did. And it works out. Like, this is a real technique, but we never really are taught the proof. And that's because the proof requires lots of topics, concepts that are from higher up math land. It's well beyond the scope of a Calculus 2 class to prove partial fraction decomposition. And in fact, many schools around the world and the country are actually opting out of teaching partial fractions. But I thought, I figured, might as well teach you because there are still plenties of schools and institutions that do teach it. And I'm going to take one step further, and I'm going to give you the proof. I'm going to give you a proof of one specific case of partial fraction decomposition, because there are lots of cases, and to check them all requires lots of concepts. I could fill up probably several videos explaining it, but I'm going to prove one specific case. I'm going to prove that I can decompose the function p 1 over p times q, where p and q are the roots of a polynomial, like a quadratic, say. Let's say those are the factors of a quadratic, kind of like we have here. So what I'm going to introduce something called Bézout's identity for polynomials. And essentially what that says, this is the only higher level math technique I'm going to introduce. And essentially what it says is if p and q do not have any common factors, there are two polynomials, a and b. We don't know them, we just know that they exist, such that AP plus BQ must equal 1. Alright? And I'm not going to prove this. This is a very complicated thing to prove. I just want you to know that it exists, okay? And now, what we can do now is, now we don't know A and B, but we do know that this formula will hold. So let's just replace the 1 in the numerator with this one here. And so when we do that, we can say that AB, or AP, plus BQ all over PQ, this must be equal to, well, we can break apart this into two different fractions, all right? So let's do that. We have AP all over PQ plus BQ over PQ. And now we can see that some things cancel. These p's and these q's cancel. So we can rewrite this as a, remember that's our polynomial that we don't know, but we just know exists, over q, which is one of the factors, plus b over p. Now this is already starting to look like something similar to what I explained earlier. But how do I know that a and b are constants? Well, it turns out these a and b's, they have to be less than the degree of p and q. So a must be, the degree of a must be less than the degree of p, and the degree of b must be less than the degree of q. All right? And so what that means is if p and q are of degree 1, that means a and b must be of degree 0. But a polynomial of degree 0 is just a constant, right? And so that's how I can conclude that if p and q are factors of a quadratic, a and b are constants. All right? And now this is exactly what I wanted to prove, right? Here I have some constants over our factors is equal to the original thing. So if I rewrite everything out, what I get is we have 1 over PQ, which are factors of some quadratic. We know that this is equal to some constant A over one of the factors, Q, plus B over the other factor, P. All right? And so this explains why we can do partial fraction decomposition, at least for this case. The other cases, there are certain rules that you have to follow, all right? And I will 100% explain how, well, I will explain a few things in the next video. I'll explain how to find A and B, right? Because this doesn't work with just any A and B. It has to be a specific A and a specific B. And I will tell you all the rules for all the other cases, not just factors of a quadratic. All right. So that's the end of the video. Keep a lookout for the next video and feel free to subscribe.